So calcium is an important mineral. This is going to be us kind of talking a little bit about osteoporosis today. I just started the recording. It's used so much that it has to be replenished through our diet. So we need to get calcium from the food that we eat. It helps maintain the strength of bones and structure, along with another thing, phosphorus. Specialized cells and tissues are responsible for adding or removing calcium depending on the amount. So we talked about osteoblasts and osteoclasts. So osteoblasts build, osteoclasts destroy. So that means that only 1% is normally found outside the body in the terms of not in bones. So 99% of calcium is stored in our bones, and it can be released by our bones if our body needs calcium. And all the calcium that we take into our body needs to be stored into our bones. So this is kind of a couple things that calcium allows us to do. It's really important for muscle contraction and blood clotting. So it's like a very, so we have reproductive system, we have muscular system, we have nervous system, and we have our cardiovascular. So it's important for a lot of different systems in the body. So calcium is needed to pump the heart and have nerves work. So calcium is really, really important. So osteoporosis is a condition where bone starts to be broken away. So osteopenia is this process where bones slowly start to degrade as we get older. So it's natural for us to kind of lose bone density as we get older. That's why older people are more tend to break bones more easily, because their bones get weaker over time. So bones break down over time. But if it breaks down too much, this is what we call osteoporosis. This is where bones become very fragile, porous, and brittle. So we can see this is a normal bone. It's nice and dense. There's holes, but they're not big and empty. This is osteoporosis. So you can think of your bones become like really brittle. Being over the age of 50, these are some of the risk factors. One of the questions today, they're going to ask, what are some things that you have that are risk factors for osteoporosis? Most of us will not get osteoporosis in like before later in life, but it's good to identify some of these conditions now. So some of these, so low estrogen or testosterone, being female is another one. So a lot of this comes with natural hormone regulation. So male and female hormones are different. So women are a lot more prone to being suffering osteoporosis later on in life. Cool. So there are some X-ray machines that allow us to look at density of minerals. So we can actually take an X-ray where we not only see the bone, but we get to see like the little pores in this. So this is kind of what they're looking for. They're looking for high bone density, meaning that it does have holes in it, but it's not large empty spaces. And some of the things that we can do for osteoporosis, diet changes, so increasing the amount of calcium that you have, exercise. They always say exercise fixes everything, but exercise does have huge global things on your body that really help with different systems. And then medication. So you can have medication that helps your body take in more calcium or use calcium in your bones. Okay. So for today, what we're going to be doing is we're going to go through a lab together. So this lab I'm going to do on the doc cam. And so we'll look at the procedure for today. We'll get our initial data down, and then you guys will have some time to answer some questions about osteoporosis. All right. So here's kind of the scenario. You're a family physician at Hasby Medical Center. You have informed a 43-year-old female that her bone density starts to show early signs of osteoporosis. So you've done an X-ray and her bones are starting to look a little bit in between the normal bone and this bone. So you can imagine it would be this, but with somewhere in between, right? So she's somewhere in between this. And at 43, that's younger than that 50 onset, right? She's a 4-pack a day smoker and does not really want to change her lifestyle habits. That happens all the time. Or take calcium supplements. The patient does not understand why it's such a big deal that she's losing calcium, and she thinks that it's just a lie made up by calcium supplement companies, right? It's just a big pharma trying to get us to take a bunch of medicine that we don't need, right? People do this all the time with doctors, right? They find some crazy thing that they find on Facebook, and they think they have a medical degree now. So what we're going to try to do is we're going to try to simulate, right? We're going to make a visual example to show the impact of calcium loss on bone tissue. So we're going to set up the following for our experiment. We're going to conduct the experiment over the next week to show the patient what happens when important minerals are lost. So the main idea of this is we're trying to show how calcium being lost is a bad thing for bones. All right, so let's go ahead and take a look at our setup for today. So what we're going, oh, actually, before we do that, let's actually look at the data table so that makes a little bit more sense before we get into it. We're going to go through the procedure together. I'll include a link in case you guys want to do the reading as well. Really, I just want us to kind of get an idea of what we're doing for our experiment. So it could be something pretty simple. So this is kind of our big thing is the data table here. We're going to be recording the mass and taking some observations for each of these different substances. So we have water, we have vinegar, and we have bleach. We're going to put bones in each of these substances. We have 3 bones. We have 3 cups full of these different substances, and we're going to measure the mass over time. So we're going to look at how the mass changes over time. So if the bone density, right, if the bones are starting to become less dense, what do we expect to have for the mass? How is the mass going to change if the bones are becoming less dense? What kind of data are we expecting? Because the goal is to simulate loss of calcium. So if our bones are losing calcium, how would we measure that using our scale? What should we see when we run our experiment? Because we're making observations over time, right? We should see a change in our mass. So we're going to see if there's a change in our mass. Water is going to be used as our control. So that water is just going to be kind of our baseline to see if things change. For the bones themselves, I try to get ones that are kind of similar in mass. That way we don't have a huge difference when we start. Okay. So we're going to make a couple predictions too. This is what we're going to do after we actually start our experiment. So what liquid is going to cause the biggest loss in calcium, and how will we measure the amount of calcium lost? So those are kind of our 2 questions. And then for our procedure, I might want to swap this around. Well, let's go through the lab and then we'll start filling stuff in. Okay. All right, so here's kind of our setup for today. We have 3 bones. What I want you guys to do right now, we're going to just kind of look at these and see if there's any major difference. So these are our 3 bones. They've been sitting out. These were chicken bones that I had for dinner a week ago. So they've been sitting out. They're dry. I don't know if you can't hear that, but they're dry now before we do anything. So these have been sitting in the same conditions. We have water, vinegar, and bleach. So what I want you guys to do is I want you to make some observations on this. So I want you to take a look at them in terms of color and like our strength. So I'm pushing, whoops, hold on a sec. I'm pushing, but it's not going to break. So all of these I'd say are pretty strong. So what we can do is I want you guys to just make your observations about make your observations for the initial for water, vinegar, and bleach. I want you guys to just write down what they look like for their appearance. For the description, they are dry. And yeah, and they feel a little bit rough to the touch, especially around the ends. You can see, like, you might be able to see some of the holes. They feel rough around the ends. So I want you guys to make your observations. I'm going to go ahead and put back up the screen. So we're going to fill in the data table right now. So I'll give you guys some time to make your observations on these. Let me see if I can get more light on that. Oh, actually, that's way too bright. Never mind. Sorry. All right. So for our experiment, we're going to be taking the mass of each of these. So for the first one, I'm going to go ahead and just put these on here on our scale. And we're going to measure the mass. So water starts off as 5 grams. Our vinegar is 4 grams. And our bleach is going to be 6 grams. So we have 5, 4, and 6. And let me try to do this again so that the scale is a little bit nonsense. So I'm getting 6 for water. I'm getting 5 for bleach. I'm getting 6 as well. So we'll go with the bigger amount for this. Again, this isn't precise. Like, these kitchen scales aren't made to go to the nearest gram. But we'll start with 6 grams of water, 5 grams of vinegar, 6 grams for bleach. So that's going to be our starting mass for each of the bones. So what we're going to do for our experiment is, it's pretty simple. We have 3 glasses. So we have water, we have vinegar, and we have bleach. So we're going to put our bones inside these glasses, fully submerge them in water, and we're going to check on them over the next couple days. So we'll get our experiment started. I'm going to put my first one in water. I have vinegar. I have bleach. So we notice some of these are floating a little bit. So I'm going to get something to weigh these down a little. But that's really it. We'll take them out each day and we're going to record what they look like and the mass each day. And we're going to see if we notice a change. So these were our initial values. So you guys should be able to record your data from there. So we're going to look and see if we notice any color changes, any changes in texture, any changes in mass.